Hello and a very warm welcome to you to the channel. I recently encountered a problem in my soils mechanics laboratory which I thought was very interesting, and after figuring it out I decided to make this video that hopefully might help someone else if you ever encounter something similar. So what you are looking at here is two soil samples. One has 50% fines, and when I say fines, I mean fraction of soil that is finer than the number 200 sieve size, and then the other is clean granular soil, could be sand or gravel. And what you're trying to do is mix these two soil samples to get another soil that has only 20% fines. So now the question is, how much of this do I need to add to how much of this in order to get me this fines percent? So if you say take 100 grams of this one, how much of this do I need in order to get me this fines percent? In other words, that ratio of the weight of this soil to the weight of that soil. How do you figure that out? Now you could go old school and sieve these two separate soils, separate it into various fractions, and then only take 20% of the fines and mix it back in, and that'll get you there. But I don't think that's a very efficient way of doing it, and I think you might agree with me, it's not very efficient to do that. So hopefully what I'm going to show you today will prove more efficient than that. And so see if I can give you a real life case where this might be important. Okay, let's say for example you are designing soil improvement, right? You have a site where this type of soil exists, and then you want to see if you can improve the strength of your soil by mixing it with clean sand, right? But you want to see how much strength gain you're actually getting when you mix these soils. So you have to test in the lab what happens if I take that sample and I mix it with sand, reduce the fines content. How much strength gain do I get in that case, right? So let's see if we can set up and work our way through this problem. It's actually quite interesting, and I hope you find it interesting too. Okay, so let's say the soil at your site is called, let's call it soil 1, and another soil that you have in your lab, or the one that you're going to mix into your site, let's call that soil 2. And then based on your testing, you find that your soil 1 has a fines content of say 22%, I don't know, and it has a moisture content of say 15%, and then the second soil, the one that you're going to actually mix into the site, say that one has a fines content of 6%, and a moisture content of only 4%, right? So your first trial is you want to see if you only reduce this fines to about 15%. If after mixing you're able to achieve 15% fines, will that give you enough strength gain? So let's say that mixed soil, let's call it soil 3, will have a fines content of 15%. Now, first of all, you want to determine in the lab whether this will be enough to give you your strength gain. But also when you go out to the site, you also want to know how much of this soil you need to mix into this one. Okay, so I think that's the problem pretty set up. And so let's see if we can work our way through it. So first off, we know that the fines percent is simply the weight of fines. I'm going to call the weight of fines, I'm going to denote it by lowercase m, and since it's for soil 3, let's keep the name here, soil 3. So over the dry weight, remember fines percent is over the dry weight and not over the total weight. But since it's the dry weight of the entire soil sample, I'm going to give it uppercase M dry. And then this is for soil 3. So that, right? Or we can rewrite this as the weight of fines in soil 3 is simply the fines percent of soil 3 times the total dry weight of soil 3. Okay. Now you realize that all the fines contained in soil 3 are going to come from soils 1 and 2. You're not adding anything else. In other words, M3 is the sum of M1 and M2. Okay. And based on this relation, we can write the same relation here for soil 2, with M2 being F2 in this case, times total dry weight of soil 2. And we can write a similar one for soil 1, M1 being F1 times the total dry weight of soil 1. Now I'm going to work in wet weights instead of dry weights, and I'll explain to you a little bit later why we need to work in wet weights. And I'm going to use MT to denote the total wet weight. Okay, so let's see. The relation between dry weight and wet weight, we know MD is simply the wet weight minus the weight of water. Let's call that MW, water. And what's the weight of water? It's simply the moisture content times the total dry weight, right? Okay, so if we put this in here, you'd have dry weight, wet weight minus moisture content times dry weight, and that's moisture content of soil 2. Let's keep the naming accurate. All right, so from this we can, and then this is 2. You can see that the dry weight of soil 2 can be related as the wet weight over, if you bring this here and then you divide 1 plus the moisture content of soil 2. And actually this relationship, I could have come straight to this relationship because this is a well-known relation in soil mechanics. The dry weight is the wet weight over 1 plus the moisture content. But now you know how that relation came about, and then, you know, I hope you understand it better now. So that's what we have. Then we can now put this. The reason we did this was because I said we wanted to work in total weights and not dry weights. So we can put this back in here. And we have M2 being F2 times total wet weight 1 plus moisture content. In a similar fashion, we can write the same relation for soil 1, fines content total soil 1, and 1 plus the moisture content of soil 1. So in other words, we have M1, M2. If we add these two, that gives us M3, right? And this relationship here, MD, we have another dry weight here, which I would like to change to a total weight. So we can use the same relationship here, and that gives us the dry weight of soil 3 or actually that could work, but let's write it rather for this one. The dry weight of soil 1 to be the total weight 1 plus the moisture content of soil 1. The reason I did that was because now we can write the dry weight of soil 3 as being the sum of dry weights of soils 1 and 2. All right, so now that we have that, we can write this relationship in terms of all of these that we've calculated. So M3, we said is M1 plus M2. That's M1, that's M2. So F1, MT1, 1 plus W1 plus M2, which is F2, MT2, 1 plus W2. That should equal F3 times MD1 plus MD2. And MD1 is simply MT1 over 1 plus W1. And MD2 is simply MT2 1 plus W2. Okay, so this is what we have. So let's go ahead and collect terms in MT1 over 1 plus W1 on this side. MT1, 1 plus W1. And then what you have left is F1 and F3. So F1 minus F3. And on this side, let's see, MT2, 1 plus W2. And what you have left is F3 minus F2. Okay, so let's lose some of these. I'll keep the numbers so when we are done we can test the formula out a little bit. Okay, so I'm gonna come back and continue here. So we want the ratio of MT1 to MT2. MT1 over MT2. Remember, that's the ratio we wanted. That's what we started with. That how much of soil 1 do I need to mix with how much of soil 2 to give me this. So if you have a ratio, then anytime you know a certain weight of soil 1, you can just relate it, get the weight of soil 2. Good. So let's see, you would have F3 minus F2 and 1 plus W1. And this is just algebra, so we left soil mechanics a little while back. As soon as we got our relationships, it was algebra from then on. F2, 1 plus W1, and F1 minus F3, 1 plus W2. Okay, so this here is the relationship that you come out with. And so all of these are known to you. If you have this soil and that soil, you're trying to figure out how much of this you need to mix with how much of that in order to obtain 15% fines. This is how your relationship looks. And that's your 15%, or all of these are known. Now the reason that I decided to work in total weights, if we had worked in dry weights, this ratio would come out to be in terms of M dry 1 and M dry 2, which is, it doesn't look like it's a problem, but what does this mean? If you have your ratio in terms of dry weights, that means that in the lab, if you are going to mix these two soils, you first have to dry both of them. Completely dry them out, make sure there's no moisture in there, and then let's see what would happen. If there was no moisture, this would go to 0, this would go to 0, so you wouldn't have these, and it would simply be F3 minus F2, F1 minus F3, because there's no moisture, right? Okay. And what was the other thing? Yeah, so in the lab, this will be fine. You can dry them out, mix them. I mean, it might be slow, but you can do it. Now the problem is when you actually go out to site. If you've done this calculation in dry weights, and then you give your contractor what ratios to mix, and then he goes out to the site, he's mixing over, say, 2-3 acres of land. He's mixing down about 30-45 feet. In metric system, that's like 10-15 meters down in the ground. There's no way you're going to dry your 3 acres before you mix these soils, which is why it's a good thing to work in total weights, and then get whatever ratio you get is in terms of total weights, and it will work for you. Okay. Now, if your granular soil or soil 2, if you remember the diagram I started with, this one had 0% fines, not the moisture, 0% fines. So if that's the case, your F2 is 0, and if it's that case where you've dried your samples and you're only mixing it in the lab, you don't need to worry about field. These also go, and then your ratio is simplified to F3 over F1 minus F3. Now, if you have more than one soil type, and obviously you have to do this iteratively, you can take one soil, another, mix it and get this. Now this becomes another soil type with whatever properties. So you'd have a certain soil 3 with fines content of 15%, and then your other soil type, say that was soil 4, you then do with these two, go through the same procedure, and then all right. So hopefully you've learned something useful today that will help you in your soils lab or wherever you might need to go through this. Thanks for watching the video. Stay tuned, I'll be bringing you more exciting stuff. Most of it will be in geotechnical engineering, but I'll be bringing you more exciting stuff like this. Thank you for watching, and if this is your first time here, hit a like or subscribe. And if you have any questions, please post them on the comment section. I'll be looking out and trying to answer as many as I can. Thank you.